Hello once again, ladies and gentlemen. Root Beer here with question number 6 on the grade 12 scholarship paper, the written contest, the Euclid. The Euclid from 2005 to be precise. So, hopefully you got your pencils ready. I've got my electronic pen ready to go. Let's see what question 6 has in store for us. So, we got a light bulb and written. This is par for the course at this point. Middle stage of the contest, usually light bulb and written. A. Equilateral triangle ABC has side length 3, that's okay, with the vertices A, B, and C on the circle of radius 3. So A's got to be the center, doesn't it? The triangle is then rotated inside the circle, first about C until A reaches the circle, then about A until B reaches the circle, and so on. Eventually the triangle returns to its original position and stops. What is the total distance traveled by point B? Ooh, nifty. Okay. So we just need a final answer with this. No rigorous proof. Let's take a look at how this triangle moves inside the circle. That's not a bad circle. Not a great circle, but it's not a bad circle. So I'll make that basically the center there. 3, 3, 3. So A is going to be the center, and then we got B here, and then we've got C. So what happens first? Well, we rotate around C until A reaches, until A hits the side. And so then we'll have A has moved here. We'll have 3. And how far do we need to rotate around C to get this? Well, so once we've got the A, then coming off of C from 60 degrees from that is going to be B. So B has now traveled here. B has traveled in this arc, because B is moving around along the phantom circle that is around C. So we can figure out that arc length there, but let's continue on with what happens. So then we pivot around A, and so then B moves up along this big circle. Whoop, don't even know what I just did there. Probably touched the top screen. Anyway, so B moves, and then B sits here. Okay, and then we get a new triangle, and so the new B is here, and the new C is here. Then we rotate around B, but nothing happens to B because he's the fixed point that we're rotating around. And then we start to move back. So there's a new C here, and A has now moved here. And it's sort of symmetric. So we rotate B back this way. So A moves to here, now B is here again. And then finally we rotate B back around this way. So B is now where he's supposed to be again. And then to get back into our original position, we rotate around B again, but B doesn't move there. Okay. So, let's just highlight B's journey. B moves along this arc, and then along this arc. These are 60-degree arcs along circles of radius 3. Then it moves back along the same sort of length arc. So it does 4 of these. 4 arcs of 60 degrees of circles of radius 3. Okay, so how do I figure out an arc length? Right? How do we figure out any arc length? So if I had, say, theta here, angle theta, how do I figure out this length here? If I know the radius and theta, so we take theta as a fraction of the whole circle. The whole circle is 2 pi radians, or I guess we're in degrees, right? So we'll use 360 degrees. And this forms the fraction of the total circumference. What's the total circumference? 2 pi r. Okay? So we want 4 of these arcs. 4 60-degree arcs, so it's going to form a sixth of the circumference of the circle. And the circle, 2 pi r is 3 here. So we're going to have 4 times 2 times 3 times pi all over 6. 4 pi, so B travels 4 pi overall. Not a bad little question. You can see a regular hexagon appearing here, which is quite nice. But that's good. I didn't put a whole lot into the explanation there. It was more just picture drawing. I'm confident in my answer, and so I can just leave the light bulb response. What is the total distance traveled by point B? Pi this way, then another pi, then another pi, then another pi. Okay. Because a circle of radius 3 is going to have 6 pi as its circumference. A sixth of that is a 60-degree arc. We're all set. Okay, so B, the written part for the question. In the diagram, ABCD is a quadrilateral in which angle A plus angle C is 180 degrees. What is the length of CD? So 180 degrees is very special. Inside our quadrilateral, the angles all add up to 360. If 2 of the opposite ones add up to 180, then the other 2 opposite ones add up to 180. And this type of quadrilateral has a very special name. It's called a cyclic quadrilateral. It can be put on a circle. Do we need that for this question? I don't know yet. But as soon as I see opposite angles, A and C, adding up to 180, bam, this thing can lie on a circle. Okay, and that might be important. But that's immediately the connection I sort of make. All triangles can be placed so their vertices lie on a circle, but not all quadrilaterals can. You have to have the opposite angles adding up to 180 to get a cyclic quadrilateral. Okay, so that's immediately in my head. I don't know if we're going to use that or not, but that's immediately in my head. So let's copy this down, and we do have to be careful and write what we're doing at each stage. So A, B, C, D is gone clockwise, 5, 6, 4, and then 7 as the one diagonal. So I have D, we have B, A up here, C, 5, 6, 4, and 7. This does look kind of like a rectangle. Maybe I should shorten CD a little bit. There we go, that looks a little better. Okay. So what is the length of CD? Fantastic question. I'm trying to figure out what we might do with this. So I can put it on a circle, as I've said. So I'll just talk about that for a moment and write that out in case I need it. So that implies B plus D equals 180. It has to be opposite angles, by the way. So ABCD is a cyclic quadrilateral. Quad for 4, lateral for line. 4 lines. Okay. So I will add in this circle. As best I can. But I don't quite know what I want to do with this, if I even need this circle at all. DB certainly looks like a diameter, but I don't think it is. No, if DB were a diameter, then A would have a right angle there. So would C, by the way, but 5 squared plus 6 squared is not 7 squared. So, can't quite think of any properties to work with here. So I've got CD. Cosine law. Wouldn't that? Let's put an X here. So I don't need the cyclic quadrilateral. That was useless. But we've got angle A here. So scrap this. Unnecessary. By the cosine law, 7 squared is 5 squared plus 6 squared minus twice 5, 6 cosine of angle A. Okay, and 7 squared is also equal to x squared plus 4 squared minus 2x for cosine of angle C. But these guys are supplementary angles, I think. And if you add up to 180, so this is x squared plus 4 squared minus 2x for cosine of 180 degrees minus angle A. If we think about sort of the unit circle definition of cosine, we have theta here. We get cosine is this length. And if we come back by theta, so our total angle here is 180 minus theta, then the cosine is this length. It's the negative amount, so it's going to be x squared plus 4x, or plus 4 squared plus 2x for cos of angle A. So cos of A, or negative cos of A is cos of 180 degrees minus A. So this is a nice property that you can take and use. So now I've got 7 squared is expressed in two different ways. So we can say 25 plus 36 minus 60 cos A is x squared plus 16 plus 8x cos of angle A. So this cos A is bugging me, but we'll see what we can do with it. So I'll subtract 16 off of here, and we'll be left with 20, so we'll have 45 minus 60 cos angle A is x squared plus 8x cos of angle A. Alright, so that's certainly true. I don't know where we're going with this, though. Because I have one equation and only two unknowns. And it's not like this is cos of angle A squared, because then I'd bring that over a little bit. So while this is all true, I don't know how helpful this has been. I highly doubt also that I can just guess and check my way to a solution. Now I know angle B and angle D, as I already mentioned, and I crossed that out in a fit of happiness at seeing the cosine law. But angle B and angle D also add up to 180, so if we included AC, we'd have a similar sort of thing going on as well. And then B squared, or 6 squared plus 4 squared would be the same as x squared plus 5 squared, and with the cos B and everything in there. Thinking that's got to be sort of the only thing left to do, because I can't think of. We don't actually know what Actually, no, I've got a calculator. What am I talking about? I can work out what cos A is. Doi, never mind that. We'll just take yeah, silly me. Didn't need to do any of that rearranging, so this is the second time I've had to rewrite things. Cos of angle A is just 7 squared minus 5 squared minus 6 squared all over negative 2, 5, 6. So it's 49 minus 25 minus 36 all over negative 60. 24 minus negative 36 is negative 12 over negative 60, 1/5. And that's a promising number. And then we were told 49 is x squared. Well, we weren't told, we found out, is 4 squared, so that's 16. Plus 8x, and now we know it cos A. So that'd be 1/5. I was kind of hoping the 5 and the 8 might have canceled out, but obviously they don't. So let's multiply everything by 5. We'll get 245, I think, here. 5x squared plus 80 plus 8x. I'll just double check 49 on my calculator. 49 times 5, yeah, it is 245. So 245 minus 80, 165. So we've got 0 is 5x squared plus 8x minus 165. Okay. Quadratic formula to the rescue. Yes, x is going to be negative b plus or minus square root of b squared minus, but then that'll cancel out with this minus, so plus 4ac all over 2a, so all over 10. Negative 8 plus or minus 64 plus 20 times 165. So 3300 all over 10. I'm losing a little confidence because I think when I add 64 to that, I'm not going to get a square. Oh, I was wrong. 58 squared. So we'll get a 58 here over 10. So we've got to have the positive one. X is positive. So plus 58 over 10. So that'll be 50 over 10, 5. So that's weird because we got 5 and 5. So ADC is an isosceles triangle. Weird. But okay. So, yeah. Nothing else to comment on there. We've got our answer. I don't need to flip. I'll flip the page in anticipation of the next question, but there we go. CD is x, which we've just shown is 5. Whole lot of calculations, a whole lot of scribbling. If you're writing that stuff up, do take time to erase it or white it out if you're using pen. And frankly, you shouldn't be using pen of mistakes like that. We didn't need the cyclic quadrilateral stuff, but we did need cosine law. And yeah, it all went it all went smoothly. Get rid of that, I guess. So it was actually much shorter once you take out all my mistakes and misguided attempts. But wow, 5. I did not expect that. I didn't think it'd be an integer. Oh well, there it is. And as I say, we're all ready for our next question, which will be question number 7. Thank you guys as always so much for watching. And I wish you luck on the Euclid if you happen to be writing this year, whenever you're watching. And yeah, I'll see you guys for question 7 next time.